Today I will be teaching you about electric circuits using a website called PHET, and the exact address of the website is phet.colorado.edu, so that's phet.colorado.edu. On the website we go to simulations and we go to physics, and under physics, if you scroll down here, you come to what's called a circuit construction kit DC, so click on that and press play. Now, when this simulation loads, we can start building our own circuits more or less straight away. Okay, so you go into lab over here on the right. And let's start building a simple circuit. So I suppose the most basic thing you need in any electric circuit is a power supply of some sort, for example, a battery, and something to power up, in this case, a light bulb. A switch is also useful for turning the circuit on and off, so we'll drag the switch over here and we'll join it all up with wire. So get a piece of wire, join those two, another piece of wire, and we're going to join up the bulb. And join this up. Now it's important that those circles connect exactly. And the other terminal of the bulb is here. Drag this wire out. Another piece of wire. Turn it around and finally join up again. Okay, so that's our circuit. Let's turn on the switch and see what happens. So turn on that switch. Okay, so just to explain what's happening here, we've got a battery, and the way this works is a battery has chemical energy stored in it, and as soon as you turn on the switch, that chemical energy is transferred to these moving guys, which are the electrons. These are the electrons in the metal wire, and they are now the energy that came from the battery, the chemical energy, is being transferred to them as electrical energy, and they carry this electrical energy around the circuit and they dump it in the bulb as light energy, and they go back again and they go around and they repeat the cycle. You can think of it as pump and dump, which is a nice way to think about it. You're pumping the electrons up with energy in the battery, and they're dumping that energy in the bulb. So they're pumped with energy at the battery, and the energy is dumped here at the bulb as light energy. Now, some other things we can do is we can start taking measurements of what's going on. We can measure the voltage, as it's called, which is, think of the voltage as kind of like the energy in the battery, really. And that's a 9-volt battery at the moment. So we're dumping 9 volts into the circuit as it stands. Now that 9 volts has to go someplace, and it turns out if you measure across the bulb, it's also 9 volts, because the 9 volts that we pumped in is now dumped across the bulb. So it's also 9 volts as a result. So that's voltage. You can think of voltage, as I said, as the energy that's being pumped in by the battery or dumped by the light bulb. It's the same thing. Now, another thing you'll notice is the speed of the electrons going around the circuit. So let's just break the circuit for the moment and measure that as well. We can break the circuit, take out this piece of wire here, and we can introduce an ammeter. An ammeter is a device for measuring the current, which is really how fast the electrons are going around the circuit. So if we put this in here, turn it around maybe, and join up. So there you see it. We have a current now of 0.9. It's measured in a unit called amps, AMP. So we have 0.9 amps at the moment. And that corresponds to a voltage of 9 volts. Now, we can also do other things here. We can click on the battery, and the battery is 9 volts at the moment. But I want you to keep an eye on the voltage reading and the current reading. We might put the voltage reading over here beside the current so you can see them both together. If I increase the voltage on this, the current goes up as well. Go up to 10, for example. Now the voltage is 10, but the current has gone up to 1. And that's what you'd expect, because the voltage means you're pumping more energy in. If you're pumping more energy in, that means the electrons are going to go faster. And that's what current measures, how fast they're going. So you would expect that the more the voltage, the more the current. The more energy you pump in, the faster the electrons will go, and that's the current. And it turns out to be the same connection all the time. If you double the voltage, you double the current, for example. So now it's a 10 and 1. 10 volts corresponds to 1 amp. If you double the voltage to 20, it should correspond to 2 amps. So there's a clear relationship there. Voltage, the way we say it is, we say voltage is proportional to current. Voltage, double the voltage, double the current, half the voltage, half the current, etc. Now, there's another missing number there, I suppose. Voltage is always 10 times the current in this example. You notice when it was 20, the current was 2. When it was 10, the current was 1. So 10 times the current is voltage in this circuit. Where is that 10 coming from? Well, if we click on the bulb, we see the bulb has a resistance of 10. The resistance means literally resistance to current, how much it's slowing down the current. And that's measured in a unit called ohms. So the resistance at the moment is 10. And that's the missing number. And now you'll notice another relationship, that resistance multiplied by current, 10 by 2, is 20, which is the voltage. So now there's a clear connection. Voltage is current by resistance. Current is often called I for short. So now we've an equation. You could say that V equals R, I. R for resistance, I for current. And that's a famous equation in electricity, in physics. It's called Ohm's law. V equals Ri. And this works no matter what. V equals Ri. If I change resistance here, if I make it even more resistance, so more resistance means more resistance to current, which means the current slows down even more. So if we change it to 20, for example, the resistance, the more the resistance, the less the current. So we'll get exactly 20 there. So you notice now the current has gone down to 1. It was 2. But again, Ohm's law still works. V equals Ri. So Ri is 20 by 1 is 20 equals V. V equals Ri yet again. So this circuit shows us how to prove Ohm's law experimentally. And that's the end of this lesson.